Welcome to tutorial 2 of CutRight. Today we're going to talk about collision detection. For this tutorial, let's go back and use the project setup that we did in tutorial 0. That is a Simply Solutions logo example. If you guys did not save the project setup from tutorial 0, this is a perfect time to practice and to do a project setup again. Once you have the project set up again, let's move the toolpath down by 13 millimeters. To do this, we will move the G54 work offset in the negative direction using the Delta Z input box found at the bottom of the Workspace Setup tab. With the toolpath moved down by 13 millimeters, you can see that the toolpath will now collide with the fixture jaw. Let's use turbo mode to run through the simulation. To check for collisions, right-click on any line in the G-code editor. If the collision navigation lines are enabled, collisions exist. In this case, we know collision exists because we made sure of it. Let's look at the first collision by clicking on Go to First Collision. We jump to the line where the first collision happened. This line is highlighted in red to show that collision has happened. We can navigate through the rest of the collisions that CutRight found via the right-click menu. Now in this particular case, you can see that the tool did not actually contact the jaw of the fixture even though collision was detected. That is because CutRight has a tolerance setting when it comes to collision detection. To see this tolerance setting, click on Settings on the top ribbon bar and click on the Collision Detection tab. Here you can see all the collision detection settings available. Since we have a tool to fixture collision, let's change the tool holder spindle to fixture tolerance to 1 mm and see what happens. Let's hit the rewind button to reset the simulation. We then use the turbo button to resimulate the complete program. Now, let's search for that particular line. As you can see, with a smaller tolerance, CutRight no longer detects any form of collision for that line, and a few lines after since they're all at the same Z level. Let's go see where the new first collision is given the 1 mm tolerance. The cutter is much closer to the jaw. Let's change it back to 3 mm and resimulate. You can think of these tolerances as a proximity bound. When it gets to and within the set proximity, a collision can occur. These proximity tolerances exist in CutRight in order to factor in your machine setup confidence level. If you are sure that when it comes to your real-life machine setup, your fixture never varies by more than a minute amount, or the CAD model of your fixture is a very accurate representation of your real-life fixture, then you can reduce the tolerance down. It all depends on how confident you are of your setup and your machine. For this example, we only show tool to fixture collision. We did not cover other type of collisions such as tool to machine, fixture to machine, and spindle to workpiece. For these other type of collisions, CutRight lets you know the exact same way as what we saw earlier, by highlighting the line that has the collision. The only difference is that the color which they are highlighted by differs. For all machine and fixture related collisions, CutRight highlights a line in dark red. For spindle to workpiece collision, CutRight highlights a line in light red. And for tool shank to workpiece, CutRight highlights the line in yellow. Basically, the darker and redder the color is, the more severe the collision is. That is a basic rundown of collision detection in CutRight. If you have any questions, please either comment below or send us a direct message.